Okay, hi. The aim for today is to build on some of the discussion that we had last week about audio analysis and the types of data that the audio analysis gives us. We looked at two types of audio analysis, analyzing the amplitude of an audio file or an audio stream, an audio signal of some kind, and we looked at doing spectral analysis, breaking down a signal into a series of different frequency bands or bins, and then looking at the amplitude of each of those individual frequency bandwidths or bins. Okay, and today we will be focusing on how we take the data that audio analysis gives us and use it to control parameters of visual objects, such as their size or their color. So that's going to be the main sort of activity today, and we'll do that in two parts. So the first part of this video will be about doing amplitude analysis and using that to control some basic parameters of some visual objects. And then the second part of the video will be looking at spectrum analysis, which is a slightly more complex process. Technically, whilst sort of conceptually, it's not a huge leap, and we'll see why shortly. So, the first thing we're going to do is have a look at using amplitude analysis in processing. Okay, and the way that that's going to work is that we can think about it as kind of as four main steps that we'll then have to write out in code. We're going to ask processing to measure the amplitude of an audio signal. Once we've asked it to do that, it will then give us a number, which we'll store in a variable. We'll then map that number onto some kind of useful range. So if we're going to use it to control the color of something, we want values between 0 and 255, and then that will then generate a visual response. Okay, so that's what we're going to have a look at. So to do that, let's open processing. Okay. So, actually, I will make the font size slightly larger for now. Okay, so because we're going to be analyzing audio, one of the first things that we want to do is to import processing sound library and sort of all the functions contained therein. Okay, so we're going to put that right at the top of the code up there. Okay, there are two main functions that we want from that sound library. The first that we will ask for is the amplitude function, and we will store that in a variable called amp. And then we're also going to ask it for its sound file handling function, and then we will store that in a variable called file. Okay. The next thing that we're going to do is we are going to well, let's skip ahead doing the variables for now, and we will jump to the setting up the two main blocks of code that we need in our processing script. Okay, so let's do the setup. There we go. Okay. Here we are, sort of doing the. We'll remember that what the setup function does is it runs through all the code within it just once. as the code is actually kind of is run in the first instance. Okay, and of course the sort of obligatory thing that we need to do first is to specify what we want the horizontal dimensions of the window to be and the vertical dimensions of the window to be. Okay, the examples that we're going to do today are going to use 3D objects, so we need to tell processing that we are going to use, that we require 3D rendering as opposed to 2D rendering. So we put p3d as a third argument in the size function there. Okay. What we then want to do is to create an instance of the Amplitude analyzer class that we defined above. Okay, so we want a new instance of the Amplitude analyzer, and that's what's going to take an audio signal and measure the amplitude and give us a number corresponding to the amplitude of that audio signal at a certain point in time. And then what we need to do is figure out what the source of that audio signal is going to be. And because of the way that we are going to be developing projects, we will have, or you kind of, I'll assume that most people will have pre-composed their audio, which they will have saved as a kind of WAV file, which we will be using as the source for our the visual aspects of our compositions in processing. Okay, and so because of that, we're going to create a new instance of the sound file class, and then what we need to do is we need to specify a file path to an audio file on the computer, which is the sort of composition that we'll be using, or in this case just some kind of audio to test the setup with. Now you'll notice that of course this is not this doesn't point to an audio file yet. We'll come back to that in just a second. Let's just assume now that this points to a WAV file on my hard disk that it's going to load up and play. I'm going to want the file to be not only played but to be looped continuously, so it doesn't just go round once. What we now need to do is link together this sound file player and this amplitude analysis here. So these two things need to be connected together, a bit like plugging a patch cable between the two elements. Okay, so I'm going to the amp variable, which contains the amplitude analyzer. We are going to specify that its input is the sound file player stored in the file variable. Okay, so that final line connects those two things together, the sound file player and the amplitude analyzer. Right, let's address the fact that this file path here doesn't point to an audio file yet. Okay, so the first thing I'm going to do is I am going to save this sketch. Okay, because what we know is that when we save it, processing will put it in a folder for us. Okay, so I'm going to call this amp analysis and save it in my processing folder. You can call it whatever you like. Okay, so now if I go to my documents and my processing folder, I've got my amp analysis folder. I'm going to continue the convention of having a data folder within my processing sketch folder, and in there I'm going to store any media files that the processing sketch is going to draw upon. Okay. And so what I'm then going to do is go and find an audio file. Let's have a look. Somewhere in here we'll have a useful one. Okay, so I'm going to copy this. I'm going to put an audio file in the data folder. Okay, and we can see that the audio file is called snd_loop.wav, and that's contained in the data folder of my processing sketch folder. Okay, so now I know that I've got my I have an audio file stored in the data folder, which is itself in the same folder that this processing sketch is contained within. Okay, so the way we tell it that it's in the same folder is that we do a dot, which means look in the same folder that this code is stored within, and then within there is a folder called data, and then within that folder you should find an audio file with the title snd_loop.wav. Okay, and this should work there. So there we go. So what I've done there is I've just asked it to, I ran the code, and the only things that are in this code, there's no draw loop yet, there's just a single setup function. So it created a window that's 800 by 800 pixels. It set up the sound processing functions, and it is now looping through this audio file, which hopefully you can hear. Okay, so I'll close that. So now that I know that it can find the audio file and it can play it. Okay, so all the audio is running. Okay. Right. The next thing we want to do is to then make use of the audio analysis data that we're going to gather. Well, firstly, to gather some audio analysis data by asking processing to measure the amplitude of the signal, and then to use that to control some kind of visual parameter. Okay, so because we're going to be drawing that, let's create the draw function. Okay, here now draw is a function that loops continuously while the program is running. And so the first thing that we're going to ask processing to do is to measure the amplitude of the audio file. Okay, so the very first thing we're going to do is to measure that signal. But what we want to do is we want to ask it to well, let's see. We're going to say so amp is the variable in which the amplitude analyzer is stored. Okay, so amp refers to the amplitude analysis function. Okay, so we're going to say analyze, which will give us a value at the beginning of the draw loop. Okay, what's it analyzing? It's analyzing whatever the assigned input is. So here it's the sound file playback. Okay, so this is looping and playing back. It's been input into the amplitude analyzer, and when we tell it to analyze, it gives us a single floating point value, okay, that corresponds to the amplitude of the signal at that point in time. Now what we want to do is we want to store that single floating point value in a variable so that we can use it in the code below, and so that we only have to ask the computer to analyze the signal once, and then we can use the value gathered by that analysis sort of numerous times without having to ask it to do repeated analyses of the amplitude. Okay, so we want to store that in a variable. So the first thing that we need to do is to declare that variable up above. So because it's going to measure amplitude, I'm going to create a floating point variable called amplitude up here above the setup function. Okay, there's going to be a little bit of moving sort of backwards and forward at this point, as we need to create a few variables as we go. Okay. So what we're going to do is we're going to assign the output of the amplitude analysis to the amplitude variable. Okay. So now whatever measurement that gives us gets stored in this variable. Okay. Let's make a bit more space here. There we go. Okay. Now, other standard things that we need to set up when making a sketch. If we don't want to kind of sort of trailing figures across the screens and so on, we know that we need to redraw the background of the screen every time draw loops. So here we're asking it to paint the window white. Okay. And what we will remember from the session a few weeks ago when we started looking at the use of 3D objects in processing is that the X and the Y coordinates for it aren't usually specified within the shape creating function itself, like they are with if we use circle, for instance, whereby we have circle and then an X and a Y coordinate for the center point of the circle, and then a third argument for the diameter of the circle. Okay, that's what we do when we're working with kind of 2D objects in processing. When we're working with 3D objects, the X and the Y values, or coordinates rather, for that object are inherited from some other function, in this case translate. Okay, and because this is a nice simple example, we're going to just stick it in the middle of the screen by specifying that to translate the XY coordinates of any following object to half the width of the screen and half the height of the screen. Okay, which will plonk it right in the middle. Right then, let's start with now that we've kind of we know we're going to locate this box in the middle of the screen. Let's create a box, okay, which is the name of a 3D cube or rectangle in processing. Okay, and the only thing that box really wants to know is the size. Okay, so let's make a 200 pixel box. Okay, so here we're looking sort of face on at the box. Okay, so it appears to be 2D just because we're looking at it head on, but really it's a 3D object, which we'll see in a minute when we look at rotating it. So we want to know the size of that. Okay, now an easy thing to do here is to use the amplitude of the signal to change the size of the box. Okay, so we're going to measure the amplitude of the audio file and then have that adjust the size of this box. Okay, so rather than this being a fixed value, it's going to be a varying value. Okay, now the output of the amplitude analysis is going to be on a floating point scale, most likely between say 0 and 1. Okay, which isn't going to be very useful for box which wants values specified in pixels. So if the box has a size of 1 pixel, it's not going to be visible, or it'll just be a single dot on the screen. It's not going to be very useful. So we need to map the amplitude analysis data. Okay, we need to map the measurement that is given to us by measuring the amplitude of the audio signal onto a range which is useful and meaningful for scaling this cube in the window. Okay, and map is the important word there. Okay, so within the box function, I'm going to use map here and put the opening and closing brackets in there. Okay, and the first thing I need to tell map is what the input is. Okay, what value needs mapping from one numerical range onto another. Okay, and that will be this. Okay, it will be the amplitude measurement of the audio signal. So I said that we need to map that from one numerical range onto the other. So the next two arguments tell us what we think the original numerical range is. So let's just for now in here put 0 to 0.5. Okay, and then we want to tell it what the outgoing numerical range is. Okay, so we're going to let's say the smallest possible size, if the audio signal is completely silent, it's going to be a box 5 pixels by 5 pixels, okay, on each side. And if the signal, the amplitude measurement is at 0.5 or potentially above, the size of the box will be 200 by 200 on each side. Okay, so if we run this now, we can see the size of the box, or what currently looks like a square, changing in response to the amplitude of the looping audio file. Okay, so this is now working. One thing that we can't tell from this is that this is in fact a 3D box as opposed to just a square, just a two-dimensional square. Okay, so to look at this, what we want to be able to do is to rotate the box. Okay, and when we're doing things like rotation and so on, it's quite important sort of the order here. We want to first use translate to position the object where we want it to be on the screen, and then once it's in that place, which will determine the center point of the object, then we rotate it. Okay, that becomes that order is quite important. That's just something to bear in mind. You know, put the object in place first, which defines its center point, and then rotate it about that center point. Okay, otherwise you'll get all kinds of other sort of sometimes sort of beautiful but unexpected kind of results. And for the sake of this example, we want things to behave as we're expecting them to, for now at least. Okay, rotate will turn the box for us, and it will do that using radians. If, like me, you don't have a sort of great intuitive grasp of values specified in radians, we can use another function called radians, and that will generate we can give it its input will be a value in degrees, and then it will give us the sort of output in radians, which we can use for rotate. Okay, so I'm going to give it say 45 degrees. Okay, and that will give us that measurement there. Now what I want to do is actually here is use rotate Y, because I want to have the box spin around the Y axis. Okay, and so a good way of thinking about what this rotation is doing is we're imagining the box, the 3D cube on the screen, as hanging from a piece of string attached to the ceiling, if you like, and it's going to sort of spin round on that piece of string. Okay, so it's rotating around the Y axis, which is why we've got rotate Y here. Okay, so now we can see two sides of this cube, okay, because we've rotated it slightly. Okay, we can sort of have a slightly different angle by adjusting the number of degrees put in there, which then gets converted into radians. Okay, so now we can see that this is a three-dimensional sort of object which is responding to that. Okay, but let's have it constantly rotate. Okay, to make it slightly more interesting. Okay, And so for it to constantly rotate, this value here, which is in sort of in degrees, specifying the rotation around the y-axis, needs to be constantly changing. And so therefore, rather than a fixed value, I want a variable of some kind, and I'm going to call that variable angle. Notice that processing immediately underlines this in red, and it complains and it says this variable angle does not exist. So we're going to scroll back up here, and we are going to create a floating point variable called angle. Okay, and then processing will stop complaining. Okay, so we've got angle there. What we're going to do is every time that draw loops, we're going to increment the value of angle. Okay, so we can do angle plus plus. Okay, so that will add 1 to the value of angle, which will start at 0, and then 1, then 2, and so on, and it will keep sort of moving around. Now we can see that we're using angle here, and that radians expects that value to correspond to degrees. Okay, and so therefore we want sort of 0 to 360 for that value, but clearly this is just going to sort of keep going up indefinitely, this value. So we're going to use the modulo function here to keep that value constrained within 360. Okay, so even though the value which is being assigned to the variable angle here will keep increasing sort of beyond 360, when it gets to 361, this modulo 360 here will cause that to sort of loop back to 0. And so when it gets to 362, it'll go to 1. When it gets to 363, we'll go to 2, and so on. And so it will keep doing that until it gets to 360 again, and then it go back to 0 again. And because 0 and 360 are essentially the same, then it should give us a sort of continuous and smooth rotation. Okay, so this cube is now spinning. What we might want to do is have it rotate perhaps slightly faster. And the way that we sort of adjust the speed of that is by having increment, have angle increment by a value larger than 1. Okay, or the value that it increments by will determine the speed of the rotation. Okay, so rather than angle plus plus, we're going to do, we might do angle plus a sine 2, and it will move twice as fast as it was doing just then, or 4, and it will be going 4 times as fast as it was just then, and so on. Because we might want to sort of play around with that value and maybe even have it change at some point whilst the code is running, let's actually use a variable called speed for the speed of rotation. And processing's complaining that that variable doesn't exist, so let's go and create it up here. Float speed equals, and we'll go with 4. Okay, and so now when we run this, we can see that the cube is moving much faster. Change it to 2. Okay, so the cube's rotating at a different rate there. Okay, so far we have mapped the amplitude of the audio file, which is looping, onto the size of the box by mapping an expected range of 0 to 0.5 onto a range of 5 to 200, which we're using for the dimensions of the box. Okay, because we are storing the value given to us by the amplitude analysis in a variable, it's quite easy for us to use that that amplitude measurement in a number of different locations in the code to control a number of different visual parameters. Okay, so we can use it to control, say, the transparency of the cube. Okay, so to do that, we would need to sort of give it a color in the first instance, okay, or to give it a fill. Okay, and so I'm going to create a sort of pink cube here, and to control the transparency, we give fill a fourth argument, okay, between 0 and 255. Now again, the value stored in amplitude is going to be something between 0 and 1, which isn't going to be very useful for specifying transparency, which is determined by values between 0 and 255. So we need to map it onto that range. So again, map becomes the key word here, where here we mapped amplitude, that 0 to 1 value, onto a range of 5 to 200. We're going to use it to control the transparency of the cube here. Okay, so I'm going to go map. The input of map is the value stored in the amplitude variable. We're assuming that it has a value between 0 and 0.5, and we want the output to be 0 to 255. And then I'm going to close the fill function, semicolon. Now, again, just to kind of reiterate what this means here, this mapping, we're going to map whatever value is stored in amplitude onto this outgoing range. We need to tell it what range we think at the value stored in amplitude falls between. So that being 0 to 0.5. So if the amplitude measurement is 0, if the value stored in amplitude is 0, then the output of this mapping function will be 0. If the value stored in amplitude is 0.5, then the output of that will be 255. And anywhere between those values, those input values will fall somewhere between these outgoing values. Okay, so that should now control the transparency of the cube here. So now, when the signal is louder, the box is not only larger but appears sort of more solid. As the signal is quieter, the box shrinks in size but also becomes sort of more kind of transparent. Okay, yeah. If I want it to sort of to make the cube bigger, then I can adjust the play around with the mapping values. Okay, so rather than have the maximum size of the cube be 200, let's make it 500 and run that there. Okay. And we can just keep playing around with these values now. Okay, so we're getting the amplitude measurement, we're mapping it onto useful ranges, and we're using it to control the parameters of the visual object on screen. Okay, we could have the amplitude control, say, the speed of the rotation. So because I don't want to keep sort of typing the same thing out again, I'm just going to copy and paste this, stick it over the top of speed here for now. Map amplitude 0 to 0.5 onto a range of 0 to 15. Okay, sorry, 1 to 15. So now the amplitude of the signal determines how quickly the cube is moving. Okay, we can have it the angle sort of move in both directions by, say, perhaps using specifying the output range here from minus 15 to plus 15. Okay, So a quiet signal will mean it's turning in one direction quite quickly, and a loud signal, it will be turning in the other direction very quickly, and anything else somewhere in the middle. Okay. Maybe you don't like magenta as much as I do. So what we're going to do is we can scale the red content of fill by copying and pasting this mapping, which is already on a numerical range useful for specifying color values, onto the red argument of the fill function here. Okay. Okay, so now the amplitude is also controlling the kind of color. Okay, and we can just kind of keep playing around with this. So now we have got the amplitude of the audio sample that we are using being mapped onto the size of the object, the speed and direction of its rotation, the color of the object, or rather the red component of the object's color, and also the transparency of the object. Okay, I might make it slightly neater by adding no fill or something up above. Oh, sorry, not no fill, no stroke, to get rid of that black line. Okay. Okay, so there's a basic example of how we import a pre-composed audio file, how we ask processing to analyze the amplitude of that signal at a given point in time, how that request to analyze the amplitude gives us a floating point value, and then by using map we can map that amplitude measurement onto a numerical range that's useful for whatever parameter we're trying to control, whether that's the size of an object, its position on the screen, its color, its transparency, the arc of a curve, whatever it might be. Okay, yeah, that's the first part of this session. The second part we will look at something which uses a lot of the same principles but does it for a slightly more complex analysis, that being spectral or frequency analysis. Okay.